All right, everybody quiet. We are going to go through this. How did you start it? Maya Brownlow. How'd you start it?
I boiled the bean.
Right on. So you got x squared plus 4x minus 3x minus 12. Now, I can do that fast because I'm old and I'm a teacher. It's first, outside, inside, last, right? So that's what I did. First, outside, inside, last. Good. Don't forget about this guy. And then did you do anything over here, Maya?
I did distribute.
That sounds like a winner. There we go. No more questions for you. I'm going to move over to Bryce. What'd you do next, Bryce?
I take away those white terms there.
Okay.
Minus 3x and add 5x.
Exactly. If we're paying attention, we've got this one, and this one all on the same side, don't we? So 4 minus 3 is 1, plus 5 is 6.
Minus 12.
And then you have minus 12. Okay, so far so good, everybody? Yeah. All right. Okay, Fox. What did you do next?
I subtracted 2x.
Yeah. Because this is a quadratic equation, we need to get a 0 over here. So you subtracted 2x and added 14. So subtract 2x, add 14. So we got our 0 over here, and we have x squared, 4x, plus 2. Now, at this point, if it factored, you could factor it if you wanted to. If you want to complete the square, you can complete the square. When I did my quiz, I did what I always do. I used the quadratic formula. It doesn't factor, but you could have completed the square. I'm going to go ahead and use the formula. So x will equal, all right, here we go. Negative b will be negative 4. B squared minus 4 times A times C.
Yes.
Oh, Jabron asked this. Jabron knows.
All right, Ron, what do I do next?
First, we need to multiply 4 times 1 times 2 and you get 8.
I wrote down
Then you take 16 and subtract
Did?
So I get 8.
I know what you're talking about.
Wait.
Wait, so I get 8?
and then you have to, it ends up being 2 roots. I don't know.
Does. And then
You have to do the trifecta, which is, bam!
negative 2 plus or minus root 2. How many got that?
I hope I put the name
I did.
aside,
Good.
but I got that.
Okay, so I didn't hear that the birthday bonus was offered. Can I like grab my sheet?
I'll ask you one for you. You need to pay attention.
I was really focused on the problem.
All right. Now, let's look at our homework. Who had a question about a homework problem?
I did.
I'm looking on page.
I have an 8.
Okay, I'm looking on page
One
100.
yesterday.
All right, Jack.
Number 15, please.
You said 50. All right, now, I'm not going to shout over you. We've got a lot of important stuff to do today. So I need everybody focused and paying attention. I'm not so interested in you graphing this on your calculator, although that's what the directions do say. I am very interested in you being able to tell me the domain. So let's review what we learned yesterday about domain. When it comes to domain, there are only 2 things you need to worry about. Katie Thomas, do you remember either one of the 2? Okay, I gotta be concerned if it's a fraction or radical, but you're exactly right. What concerns me about fractions?
If like there's a negative number.
Okay, you're gonna mix it back. It's the denominator, so what do I not want in my denominator? zero. I never want 0 in the bottom. Am I interrupting something over here?
We're talking about math.
We
talking about how she found.
Do you suppose that what I'm saying is remotely important to any of you over here?
Yes.
Okay, then we should be paying attention, all of us, okay? I realize that putting you, this group of girls at a table is probably not a good idea, but I really, I can't help it. This is what I have. I need you to pay attention, okay? Maybe your grades would come up. All right, number 15. Number 15. Here's the equation. Now, this has a tricky piece to it, Jack. I can see why you asked this question. It has a little bit of a tricky piece. When I do domain, I have to be worried about, as Katie told us, the radicals and the fractions. This problem has both. So I'm going to deal with the radical first. Remember our rule. Whatever is under the radical, in this case 4 minus x, has to be bigger than or equal to 0. That's the rule. So I'll solve this. Subtract 4 from both sides. Now I'm going to have to divide by a negative, right? And that's going to switch my symbol. So far my domain is everything less than or equal to 4. But I also have to worry about the fraction part, because another one of my rules says the denominator cannot be 0, which means nothing in the denominator can be 0. So this one's easy. This says x can't be -1. So far I have 2 parts to my answer. This is the first part. Now I've got this. This is the tricky one, because we actually had one like this yesterday.
Not possible.
It's not possible, because when you try to solve this, you see what happens?
You have to square root it.
You square root it, and what's going to happen here? And we said no i's. So I don't even worry about this part of the problem, because it doesn't make sense. It gives me imaginaries. Okay?
Yeah, I thought you were supposed to so do you put factor in all
Just
the
ignore
x?
that.
Okay.
Yeah, you can't factor that.
No,
Oh.
the x plus 1 at the very beginning.
Oh, you foiled this
Yeah,
out?
foiled,
Oh, yucky, yeah. No.
That's what it is.
No, we don't want to do that. If we're solving the equation, we would do that, like we did on our quiz, but not when we're doing domain. Okay? So these two are your answer. All right, did anyone else have a question about a homework problem? Anybody else? Fox? 12. Now, again, this is a domain question. This isn't a solve equation. This says, what is the domain of this function? Okay, Suzanne? Now, here's the deal. There are 2 things I have to worry about with domain. What are they? Stop it. You gotta know this. We talked about it yesterday. I gotta worry about radicals, and I gotta worry about fractions. Now, does this problem even have a radical in it?
No.
So I'm not even, that's out. I don't concern myself with that. But it has 2 fractions, right? And what do I know about fractions? The denominator cannot be 0. So x can't be 0, x minus 3 can't be 0. Kids, that's all there is to it. When you are talking domain, there are 2 things you have to worry about. The denominator can't be 0. So I wrote that down. If I had a radical, whatever is under it has to be greater than or equal to 0. But I don't have one. So what's my answer, Suzanne? It's real easy. X can't be 0, and x can't be 3. 3. That's it. That's your answer. That's the domain. All right, let's do one more. Who else has a question about one of our homework problems? Maya, was your hand up?
Yeah, but then I just returned.
Bryce? 13. X over x squared minus 5x. All right, Bryce. This is a great question. And it's going to lead us directly into what we are going to start with today. Did I copy that right? Yeah. Okay. Now, question is domain. Are you listening? The question is domain. What do I have here? I have a fraction. So that means that my denominator cannot be 0. Now, before I do that, well, let me just write that down. So x squared minus 5x can't be 0. Now that's a quadratic, isn't it?
Yep.
I need to basically solve this. I know it's a not equal to instead of an equal to, but it's the same idea. I need to solve this, but it's got a squared in it. Maya? Oh, so Maya says, Mrs. Ford, I need to factor, or I need to solve this problem. Factoring is an option, right? So I'll just take out an x. Now, Jack, we're back to where you were with the question you asked about. There's 2 of them. Neither one of them can be 0. It's like Suzanne's problem. Neither one can be 0. So x can't be 0. X minus 5 can't be 0. Which means x can't be 0 and x can't be 5.
Good job, Tim.
Okay?
What?
Now, what would we do if this denominator had like a +4 on it? What would I do now? Because now that would be not equal to 0, so what would I do here? I'd factor it, right? I'd do this. And I'd still get 2 different answers, right? Yeah. Good. Let's do one more. Was there another one?
There's 11.
Well, do I need to do it?
Oh, no.
Yeah, I know there's more problems,
Oh.
but are there more questions you had about problems?
He's so mean. On 15, would you do something like that too?
15, I already did. That was the first one I did, Katie. 15, I did that already.
That's probably the one where we were
Could be. Bryce? All right, this is the last one because you're losing attention. Problem number 11. Okay, Bryce. When I talk about domain, there are 2 things I have to worry about. What do I have to worry about? The denominator, I have to worry about fractions because the denominator can't be 0, and I have to worry about radicals because what's under has to be positive. Now, there are no radicals. Don't worry about it, but it does have a fraction. Whatever is in the denominator, and in this case, Bryce, there are 2 things in the denominator. Whatever is down there cannot be equal to 0. Which means x cannot be -3 or x can't be 1. So there are 2 things x cannot be, so you write both of them down. They're both the answer. So your domain, technically then, is every number in the whole wide world except those 2. And we learned yesterday, and are going to continue today, that if I graphed this, problem, I would have an asymptote at -3 and an asymptote at 1.
So are we supposed to like that?
No, all you had to do here was list the domain. That's it right there. That's the answer. Now, when the question says what are the asymptotes, then we'll graph it. But this was what's the domain.
So if you get 0, you have to put that as one of your answers, or you do.
If you get 0, you do.
Okay.
Yeah. So if it says x can't be 0, then you have to write that down. X can't be 0. Okay? All right, let's get our notes out then. And yesterday, we made good progress, but we got to this point where all of a sudden the problem got really tricky. And that's where we're going to start. Ron, I can't believe that you're playing whatever game that is in that class. Can't happen. Okay? Next time I'll take the stupid iPad and do something. Okay. E. Everybody is on note sheet number 9. Note sheet number 9, problem E.
That's my lucky number.
Now, okay, this is tough. This is tough. I need everybody's complete focus. The directions say find the vertical asymptotes. That's what the directions say. Yeah. Now, yesterday we talked about the fact that vertical asymptotes come from what x cannot be. They come from letting your denominator equal 0, which is sort of like what we've done with domain. This problem is tricky though, because would you agree that I can factor the top and the bottom? Yes. How would the top factor? Will?
X minus 1, X plus 1.
Yep. Now, will somebody factor the bottom for me?
X minus 4, X minus 1.
I don't
X plus
think
5x minus.
x plus 5, x minus 1. Remember, we have to get a 5. So we couldn't use 4 and 1. 4 and 1 wouldn't work. We need a 5. And it's plus 5 because that's a plus 4 there. When I FOIL it, look. Outsides are -1. Insides are 5. -1
I've
plus
always
5.
struggled with that.
Yeah, but you know what? You can do it, Katie, if you just check your answer. You can write down your first thought, that's okay, but then check it to make sure it's right. Maya?
When you have your factors and you have to send equal to 0, you have to like write that out or you can do it in your head?
Oh, no, you can do it in your head. But here's something that hasn't happened to us before. What do you notice about this problem?
There's an X minus 1.
Exactly. Kids, listen, we gotta cancel that out. So your big, huge, ugly, hideous problem boiled down to a much simpler problem, right? Now, this is the new part. With rational functions, with functions that are written as fractions, they're called rational functions. There are two kinds of what we call discontinuities. One of the discontinuities is the vertical asymptote. I can look at this problem and tell you I'm going to have a vertical asymptote at x equals -5. Because what happens if I plug in -5?
You get 0.
I get 0. And am I allowed to have a 0 in the bottom? No. Okay, so vertical asymptote, whatever makes the denominator 0. But this guy used to be in the problem. He is part of the original problem. So even though I'm allowed to cancel him out and rewrite my problem, I can't ignore the fact that there was a problem. If I let x be 1, I would have also had a 0 in the denominator in the original problem. Would you agree with that? So that's called a removable discontinuity, and it is graphed as a whole. So when I do my picture, I'm not only gonna have a vertical asymptote, but I'm gonna have a hole, I'm gonna have an open dot in my picture. And the open dot is gonna happen where x equals 1. Okay? Now, I know this is tough. This is hard stuff. This is the real deal. We'll do some more, don't worry. But here's the problem. Here's what's going on. Let's back up to this. If I said, what's the domain? You would all say, x can't be -5 and x can't be 1. Would you agree with me?
I agree.
These are what we call the discontinuities. These are the things that break up the picture. Discontinuities. These are the things that break up the picture.
Quick question, why is it x equals 1 instead of x equals -1?
Okay, because remember, x plus 5 can't equal 0, x minus 1 can't equal 0.
Oh, that, we're talking about the denominator.
Uh-huh.
I got you.
Yeah, I'm only in the denominator. Because remember, this whole conversation is only about the denominator. Domain, asymptotes, all that is only the denominator. Now, these are called discontinuities. These are the places that you say to me, Mrs. Ford, x cannot be this, x cannot be this for the domain. Now, but they're different because this one is still in the problem, but this one canceled out of the problem. Do you see that, how they're different? So this one is called non-removable because I've still got it. This one is called removable because I could cancel it out. If you can't cancel it out, it's going to show up as a vertical asymptote. If you can cancel it out, it's going to show up as a hole. So when x equals 1, I'm going to have a hole because that's the one that canceled out. Now, how do I get my y coordinate, do you suppose? Because the hole is a point. It's going to be, we're going to graph it as an open circle. How do you think I'll get the y coordinate? If I know that the x is 1, I'll plug it in. And if I plug it in, if I put in 1, I get 2/6, which reduces to 1/3. So this problem has a vertical asymptote at -5, because where do vertical asymptotes come from? Where the denominator equals 0. That would be, oops, I erased it. That would be 0 if x were -5. How do I get holes? Holes happen when I can cancel. And the x coordinate is what makes the cancel factor 0, so that would be 1. And then you plug that in and get your y.
What'd you plug it into that one?
Right here.
Oh, I figured it out. Okay.
What if,
Go ahead.
well, I was gonna ask the problem that's next.
Okay, we're gonna do the next one.
I was just gonna ask if you flipped it.
What number did you plug in?
She plugged in.
I plugged in 1 into here, so I got 2/6, which reduces to 1/3.
I got like.
All right, gang. I need your attention. This is hard stuff. It's tricky. You've never done it before. Gotta pay attention. F. X squared plus 9x plus 20 over x squared minus 16. Olivia.
When we literally draw a hole on at 1,
I didn't graph it. Yeah, you would have 1, 1/3, and you would have just an open circle there. In addition to your asymptote that's back here at x equals -5. All right, everybody focused on problem F now?
Wait,
I got this
why
one.
does,
So now
why
we're
does,
doing,
why does x equal -5 then? It doesn't. It would.
okay, it can't be -5. That's where the asymptote is. That's its vertical asymptote. So I'm going to draw a line at x equals -5 because x can't be negative 5, so I have to put an asymptote in my picture.
So where's that point at exactly, like?
Right here.
3, 1?
No, it's over 1, up 1/3.
Oh, okay.
Over 1, up 1/3. Now, I'm looking on F. Here we go. Everybody's focused on F now. So if you're still looking at E, stop it. Look at F now. I think everybody knows how to start.
Factor.
Yep, you're gonna factor everything. Veronica, can you factor the top or the bottom into 1 for me? Is. Perfect. That is exactly right. Can anybody do the top for me?
5 and
Katie?
4. X was 5 and X was 4.
Yep. Now, boys and girls, there are 2 things x can't be in this problem. If I'm talking domain, there are 2 things x can't be. X can't be what?
Negative 4.
4. X can't be
Negative
4. That's my domain. But when I take a close look at this fraction, I notice these cancel. Right? Leaving me with x plus 5 over x minus 4.
Right.
But remember, there were 2 things x couldn't be. So there's 2 problems here. One of them x still can't be. X still can't be what?
4.
4. That means there will be a vertical asymptote at x equals 4. So your vertical asymptote is x equals 4. You still can't be 4. This problem is still there.
So does that mean x equals, or does that equal -4? It's not removable?
It's a removable discontinuity, which means it will be a whole. So what will be the x coordinate? What did we cancel out?
4.
We cancel out plus 4, x plus 4, which means -4 will be my x coordinate. Maya?
So you don't include the asymptotes when they ask you about domain? Is whole like a completely separate?
No, whole is part of the domain too.
Oh, so you
Because
still include even.
when you tell me, when you do your domain, Maya, and you say x cannot be something, whatever that is will either show up in the graph. Every x cannot be will show up in the graph as either an asymptote or a
Oh,
whole.
so whole just another way of like showing me.
Yes, whole is the one, if it cancels out, it'll be a whole. If it doesn't cancel out, it'll be an
But
asymptote.
you still include.
But they're still part of the domain, yes. Now, how do I finish this? How do I get the y coordinate?
-4 plus 1.
I'm gonna plug it in right here, my new problem. So I'm gonna put in -4, so I have -4 plus 5 and -4 minus 4. What does that end up as? Top would
1
be
over
1.
1 over -8.
1 over -8. So if we were graphing this, if we were gonna graph this, we'd have a vertical asymptote at x equals 4, and we would have an open circle at -4, -1/8.
Yeah.
Now, there's obviously more to the picture than that, but that's our beginning. That's, we're gonna do it in stages. That's the beginning. A whole is an open circle. Now, because we haven't had enough fun, we're gonna look at G.
What you mean, fun?
Look at G.
Yeah.
What is fun? Oh, what you just did. That was brain challenging. Almost had a
Well, you
finger.
think that was brain challenging, look at G. And remember, our clock is way fast. So we've
No,
got,
it's not.
No, it's not, it's almost that time.
It's almost time.
It's almost that time. Let's pray.
Wait.
I'm gonna make sure, I'm gonna think about the rest of the day. I'm gonna be playing tonight, and I'm gonna say this is for Miss Ford. Pre-cal stops for nobody. I'm gonna tackle him and be like, that's for Miss Ford, and act like you know.
here we go. Here we go. I think the top is okay. I'm manageable. I think the top I can do. Can you do the top?
No.
1
1
and 6.
and 6. And it had to be minus 6 plus 1?
Yes.
Now, if you're not sure about that, I want you to FOIL it out. Verify it to yourself. That gives me -5 in the middle, so I'm good. What in the world, though?
Factor.
By grouping, Olivia. Very good. So what can I do, Olivia, with the first two terms?
Take out x.
Take out an x squared, leaving me with?
X minus 4.
How about the last two?
You can't do anything.
I can take out a -1. And then if I take out a -1, I'll be left with positive x minus 4. And why does that make me happy?
Because you need the two to match.
I need the two to match.
Ooh.
So my top is still what it is. Now my bottom, I have a match, so I write it down. How many times do I write it down? Once. What's left over? After I write this one down, what's left over? X squared minus 1. What can I do with x squared minus 1? Can I factor it? Yep. Now, take a look at your problem, gang. Look at the denominator. There are 3 things down there. That means for your domain, there are 3 things x cannot be. X can't be 4. X can't be -1. X can't be 1. But some of those are wholes, some of them are asymptotes. Got to figure out what's what. What will cancel?
That's x plus 1 is
Only one thing cancels, so I'm going to have 1 hole. What will the other 2 things be? Asymptotes.
This is